Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. This is the second video, guys. Simply means I'm answering the second question from the May-June 2024 Physical Sciences Paper 1 examination. Please note that, guys, the other videos will be uploaded as well, and each and every question will have its own video, because I'm avoiding to have long videos, né? And guys, it's very important for you to know how to tackle exam questions. I believe it will strongly give you an edge whenever you write your exam. So please do share the video to your peers so that they may have the same edge as well. Okay, block A of mass 4.1 kilograms is connected to block B of mass 2.3 kilograms by a light, inextensible string passing over a frictionless pulley. Block A is at rest on a rough horizontal table, and block B hangs vertically as shown in the diagram below. A force F of magnitude 49 newtons is applied on block A at an angle of 50 degrees to the horizontal, causing block A to accelerate to the left from rest along the table. Okay, the coefficient of kinetic friction between the surface of the table and the block is 0.35. Before I even start, guys, let me just draw free body diagrams for both blocks rather, né? For block A, I'll simply have an applied force which is at an angle. That's force applied. Please, guys, whenever I draw a free body diagram, né, do not write like me. Please label your forces completely, né? This is F applied, and yes, the block is in the universe, so it will experience a gravitational force which is always vertically downwards towards the center of the Earth's surface. This is the weight, and since the block is on top of a surface, the block will experience a normal force together, and then there's kinetic friction between the block and the surface, so there is kinetic friction experienced by the block as well as the tension on the string together. You can draw your free body diagram like this, or draw the one that has the components of your applied force. Remember that, guys, your applied force was applied at 50 degrees, né? The one that has the components will simply look like this. Yes, you'll still have your normal force, and yes, you still have your kinetic friction, you still have your tension, you still have your weight, and then there is both the horizontal component of my force and the vertical component of my force, né? The horizontal component is always the magnitude of the force, which is 49 cos 50 degrees. That's 49 cos 50 degrees, and the magnitude of the vertical component Fy is just 49 sine 50 degrees. Alright, together. You can draw your free body diagram like this, or draw the one that has the components, né? And then for block B, we only have two forces. There's weight as well as the tension, which is pulling which might pull the block upwards. Actually, I should not say might, because since A is accelerating to the left, that means the block is being pulled upwards. Okay, now they want me to state Newton's second law in words. Newton's second law simply states that when a net force acts on an object, the object will accelerate in the direction of the net force with an acceleration that is directly proportional to the net force and inversely proportional to the mass of an object. Are you together? That's how you should state Newton's second law of motion in words, né? Others might prefer that F net is equal to the rate of change of momentum. You can state it like that as well. It's still fine for those who are in grade 12. Okay, and then now they want us to draw a free body diagram showing all the forces acting on object A while it accelerates towards the left. You can draw a free body diagram like this, or you can simply draw it like that. Né? Then now they want us to calculate the magnitude of the force exerted on block A. The magnitude of the force exerted on block A. Frictional force rather. Né? I know that frictional force is basically equals to the coefficient of friction multiplied by the normal force altogether. But in this case, guys, I cannot say my normal force is equal to the weight of my object. Why? Because I do not only have two forces vertically, but now I have three forces vertically altogether. So I know that normal force plus the vertical component must be equal to the weight. Since my body is not accelerating vertically, it simply means that the upwards forces are both equal to the downwards force, because according to the vertical movement, my object is in equilibrium. There's zero acceleration, and this simply means that my normal force is equal to weight multiplied by the vertical component Fy. But what is weight? Weight is simply mg minus F, which is the force applied, sine of theta. So this will give me the normal force in this situation. So now all I have to do is to just substitute. I know that the coefficient is 0.35, and then the weight is basically 4.1 multiplied by 9.8 minus the vertical component. That's 49 newtons multiplied by the sine of 50 degrees. All right, together. Please use the brackets correctly, guys, whenever you punch your calculator. That's 0.35 and then 4.1 multiplied by 9.8 minus 49 sine 50, close bracket and close another bracket as well. So this will simply give us 0.93 newtons. The magnitude of kinetic friction is 0.93 newtons. Our kinetic friction Fk is 0.93 newtons. Okay, now they want us to calculate the magnitude of the acceleration of a block A by applying Newton's second law. They were not supposed to tell us this, guys. Né? Please note that if ever you have two bodies like this, you will always apply Newton's second laws. Newton's second law in both objects. Are you together? You need to solve simultaneously. But let's just work. Let me write there at the bottom. Remember that, guys, horizontally for block A, I had my horizontal component, I had my kinetic friction, and I had my tension over there. Né? I'll simply focus on the horizontal forces, because these ones they do no work on my object, or rather they are not influencing my object to move. All right, together. So I'll just focus on the horizontal forces for block A, but for block B I'll simply focus on my vertical forces, because my object is moving vertically. Remember, I had the tension as well as the gravitational force for B. Né? Okay, so F net over here, F net is equal to MA. By definition, F net is the sum of all the forces in one definition. Sum means you must add. You must take the horizontal component plus your negative friction plus your negative tension. These ones are negative because they're opposing my direction, right? That's equal to MA, and hence I'll end up having Fx minus Fk minus T is equal to MA. Fx is basically 49 cos of 50 degrees. The frictional force is 0.93 minus T. This is equal to 4.1 A. And then on the left hand side, I have 49 cos 50 minus 0.93. This will simply give me 30.57 minus T is equal to 4.1 A. And that's my first equation. And then for block B, I know that F net is also equal to MA. F net is sum of all the forces in one direction. I simply have my tension plus the negative gravitational force. Why? Because the gravitational force is opposing the motion of my object. So tension minus weight is equal to MA. I don't know the tension. The mass of that's 2.3. I'll say 2.3 multiplied by 9.8 is equal to 2.3 A. So 2.3 times 9.8, this will simply give me T minus 22.54 is equal to 2.3 A. And that's my second equation. Yes, guys, I know that if you want to find A, you can make one variable subject of the formula, since we have two unknowns, both A and T in both equations. Né? But guys, the easier way to calculate these things is to just say equation 1 plus equation 2. Né? Take everything on the left of equation 1, that's 30.57 minus T, plus everything on the left hand side from equation 2, that's T minus 22.54. This is equal to 4.1A plus 2.3A. I can already see that the T's will simply subtract one another. I'll be left with 30.57 minus 22.54. And that will simply give me 8.03 is equal to 6.4A. Divide both sides by 6.4. If we divide both sides by 6.4, you'll simply get 1.25 meters per second squared. So that's the acceleration of the system. That's how, guys, you're supposed to tackle question 2 over there. So just stay tuned and wait for more videos. Thank you.